In this video, let's talk about differentiation as tested in O-level additional mathematics.
This video is part of our 5 minutes of additional mathematics series, where we go through an entire O-level additional math chapter in 5 minutes. Do take a minute to like our video and subscribe to our channel.
Alright, first let's talk about the differentiation formulas that you have. So whenever we differentiate a constant, you'll get 0. When you differentiate a single algebraic term, what you need to do is bring down the power and then decrease the power by 1. So when you differentiate x to the power of n, you'll get n multiplied by x to the power of n minus 1. Okay, you also need to know the differentiation of trigonometric functions. Take note for trigo differentiation as well as integration, the angles are by default in radian mode. All right. So when you differentiate sine x, you get cosine x. When you differentiate cosine x, you get negative sine x. When you differentiate tangent x, you get secant square x. If instead of having x, you have a function in terms of x, what you need to do is, apart from changing sine u, where u is a function in terms of x, to cosine u, you also need to multiply it by du dx. Okay, so in other words, right, if you were to differentiate sine, cosine, or tangent, you will always get cosine, negative sine, and secant square respectively. Okay, but if this is no longer x, it is maybe x cubed, what you need to do is the angle still remains the same. So if here is cosine x, if here is sine x, here will be cosine x. If here is sine x cubed, here will be cosine x cubed. But whenever it is not x, okay, you need to multiply by the differentiation of whatever is u. Okay, so if it is x cubed, differentiate x cubed, you get 3x squared. So maybe let me write it down so that it is clearer. So for example, if I want to differentiate sine x cubed, then so sine, when you differentiate sine, you will get cosine. Okay, then you also need to multiply it by 3x squared. So you need to differentiate x cubed, which is 3x squared, and you need to write it in front here. You also learn to differentiate exponential functions. So differentiate e to the power of x, you'll get e to the power of x. But if it is not x, but it is something else, basically, no, don't worry. You first copy e to the power of u here, then multiply it by du dx. So let me explain what I meant. So for example, we have d dx e to the power of x squared plus 5x. Okay, so when you differentiate this, you still have e to the power of x squared plus 5x, but you need to differentiate x squared plus 5x, which is 2x plus 5, and write it in front. Okay, so this portion here, so x squared plus 5x is basically your u, which is a function in terms of x. Okay, so when you have u, which is a function in terms of x, you need to when you differentiate it, not only do you copy e to the power of u, you also need to multiply it by du dx. Next, let's look at the differentiation of ln, or natural log. So when you differentiate ln x, you will get 1 over x. If it is not x but a function in terms of x, then it will be equals to du dx over u. Okay, so let me give you another example. So for example, if I were to differentiate ln 3x squared plus 5, okay, then remember when you differentiate it, the denominator will be 3x squared plus 5, and the numerator will be the value, or what you get when you differentiate 3x squared plus 5, which is 6x. Then we also learn about the chain rule. So when you have u, which is an expression in terms of x to the power of n, you can differentiate it by using this formula. So let me give you an example. So for example, I have d dx 3x squared plus 5 to the power of 8. So n is equals to 8, right? Then this 3x squared plus 5 is u. So what I'll do is I'll bring down the power, which is 8, power minus 1, so 3x squared plus 5 to the power of 7. Then I'll differentiate 3x squared plus 5, which is 6x. So simplify it, I get 48x 3x squared plus 5 to the power of 7. Alright, you also have product rule. So if you have two functions being multiplied together, to differentiate it, you will keep one, differentiate the other, plus keep the other, differentiate one. So let me give you an example. For example, I want to differentiate x cubed times 3x plus 5. Okay, so I will let x cubed be u and 3x plus 5 be v. So I will keep v, which is 3x plus 5. Then I'll differentiate u, which is 3x squared. Okay, then I will plus u, which is x cubed. Then I will differentiate 3x plus 5, which gives me 3. Okay, then you simplify and you'll get the final answer. Now let's look at quotient rule. So when you have quotient rule, you have two functions of x, for example, divided by each other. So you can apply your quotient rule. So keep the denominator, differentiate the numerator, minus keep the numerator, differentiate the denominator over denominator square. So let me give you an example. So let's take maybe x squared over x cubed plus 5. All right, so v is your x cubed plus 5 and x squared is your u. So I will first copy v, which is x cubed plus 5, then multiply by du dx, which is 2x. Then minus u, which is x squared, multiply by dv dx, which is x cubed plus 5. Which is 3x squared. Okay. Then I will divide everything by the square of the denominator. Okay, then you simplify the answer. So that's how you do quotient rule.
Thank you for watching and see you soon. Meanwhile, check out our other videos.